This video covers quadrilaterals that are inscribed inside of circles. It's our learning target 8. I can find the angles of a quadrilateral inscribed in a circle. Two important vocabulary terms that we're going to use in this lesson is supplementary angles. Remember that these are two angles that add up to 180 degrees. And also what a quadrilateral is. It's a four-sided shape or four-sided figure, such as a parallelogram, square, rectangle, anything like that. So this is what it looks like to have a quadrilateral inscribed inside of a circle. There are two important things that you should know about this kind of shape. First off, opposite angles are going to add up to 180 degrees. And this goes in both directions. Also, because of the way that the quadrilateral is inscribed with its angles, you do still have inscribed angles. Consider that CDA is an inscribed angle. You can use it to figure out arc AC, as well as CBA is an inscribed angle, and you can use it to figure out arc ADC. So look out for inscribed angles that are a part of these pictures to help you find missing arcs or missing angles. Here's our first example. We're going to find the measurement of X and Y angles. The 70 will make 180 degrees with the angle Y. So we can find this angle Y by taking 180 degrees and minusing 70 degrees, 110 degrees. 60 and angle X make 180 degrees. So I'm going to find angle X by subtracting 60 degrees from 180, 120 degrees. In this example, we're going to use the same exact property about an inscribed quadrilateral inside of a circle. So let's first work on the X's, and then we'll move on and work onto the Y's. In this problem, I have 2x across from 2x plus 4. Neither of these are the degrees I need to use, so I'm going to have to set up an equation that uses the fact. The fact is that they add up to 180 degrees. So I will write down both of the angle information. I will add them together and set them equal to 180 degrees. Now it's time to simplify and solve for x. 4x plus 4 equals 180 degrees, minus 4 on both sides, and I end up with 4x equals 176. Divide by 4 on both sides, and x equals 44. Now let's work on the y's. That would be my y and my 3y plus 8. Those also are opposite of each other, and they add up to 180 degrees. So I will write down both of the angle information, y and 3y plus 8. I have to add them together, and I have to set them equal to 180 degrees because of our fact. Y and 3y makes 4y, minus 8 on both sides. 4y equals 172. Divide by 4 on both sides, and my y equals 43. In our last example, we are given the measurement of two arcs. We want to use these arcs to figure out how big that x angle is. I do not have enough information inside of my inscribed quadrilateral to use our first fact, the fact about opposite angles being 180 degrees together. So instead, I'm probably going to rely upon my second fact, that I should be looking for inscribed angles to cut in half or double to find arcs or those angles. Let's identify the arc that this x angle is connected to. Here are the two sides of the angle. So the arc, the included arc, would be this yellow arc right here. Now I do not have any measurements on this arc, to divide by 2 to get my angle. So I'm going to probably have to use the information I have to begin with, the 50s. The 50s together make up this arc. That arc is 100 degrees. So I'm going to follow from the points at the edge of these arcs back to the inscribed angle it's connected to. So I can take the arc and I can divide it by 2 and I get 50 degrees. So this inscribed angle is 50 degrees. Now I do have an angle measurement opposite of the angle I want to find, so I can use my second fact about them adding up to 180 degrees. So my x angle will be found by taking 180 minus 50. It's 130 degrees. That pretty much covers the variety. You'll see examples written in different ways with different given information, but this is how you apply the 2 facts of inscribed quadrilaterals inside of a circle. Don't forget to make sure you hit the submit button in the form so I have record of you watching the video. Thanks.